Hey there guys, Berg here, hope you're doing well. So this is going to be quite an interesting video because I'm going to show you how to create IPSEC tunnels on a FortiGate firewall. Now, I feel like this might be one of the most important lectures on firewalls because besides policies, a lot of stuff that you're going to set up is stuff like VPN tunnels in order to access remote networks. You will see a lot of providers set up stuff like to the cloud, to AWS or Azure, or even to other network providers, or even stuff like banks. I mean, it's crazy. So you are definitely going to be dealing a lot with stuff like IPSEC tunnels, and hopefully this video will just show you how to create an IPSEC tunnel, how to get everything up and running, and just some of the things that I can just give you tips on how to troubleshoot some IPSEC tunnel issues if you ever run into any kinds of problems. So let's get into the video. Alright, so I've got a diagram open that I created on draw.io. Again, very useful open source software. You can create diagrams just like this, and I find it very useful to just explain what we're trying to achieve. Now, in this diagram, we're in essence going to have two remote sites, namely site A and site B. And you can think of this as a site-to-site VPN, but it doesn't need to just be site-to-site. This can be applicable to a cloud provider or a bank or whatever. So this is just two endpoints that will be forming an IPSEC tunnel. And what is the goal of an IPSEC tunnel? Well, it is there to encrypt and decrypt traffic between two devices like firewalls, so that traffic behind the firewalls, behind the networks that live on that firewall, can be sent across the tunnel securely, so that you can get to remote LAN range over the internet. And if anybody was able to intercept your packets, they wouldn't see anything because the traffic is encrypted. So that's why IPSEC is so useful. So let's actually jump into a virtual environment using these FortiGates, and we will configure our IPSEC tunnels. Alright, so here we are connecting onto our site A firewall. So I will just log in with my credentials. And what I'd like you to take note of firstly is if we want to work with IPSEC, it will all be happening under the VPN menu. So you'll navigate to the VPN, and you can set this all up in the CLI as well if you feel more comfortable with it. But I know many people just tend to use the GUI because it's really friendly. Like Fortinet really built a nice GUI to work on. So if we're going to be configuring any type of IPSEC tunnels, we can just go to the IPSEC tunnels menu. But I do want to stress out something. There's an IPSEC wizard here, and this wizard has many different types of setups that Fortinet has come across over the years to just quickly make it easy for you to configure any type of VPN using a template. Now, if I navigate to the IPSEC tunnel template, this is where you'll see the type of templates that are predefined that you can use in a wizard, where you can set stuff up like site-to-site SD-WAN, dial-up, Cisco site-to-site, dial-up Cisco, etc. Just all of these different modes that you might see people use IPSEC with. You don't need to use any of the templates to configure. It's just a quick and easy way to predefine subnets, and that the policies and routing and stuff is just automatically created for you. I just feel like it is worth mentioning that if you do want to use any type of these wizard templates, because you can select a template type like the site-to-site wizard, hub and spoke, remote access. And what we will primarily be working with is custom, because I tend to just do the custom setup because I like to make sure that I define all of the settings correctly. If we just click on IPSEC tunnels, we'll see it's currently empty, but if you create any tunnels, you will see if the tunnel is here and what its status is. But let's create a new tunnel. And this is in essence is just gonna go back to the wizard to run the wizard. Now you can give the tunnel a name, obviously. So I might make it something like IPSEC to site B or something. And I will again just set this to custom. I'll continue. And now we get to fill in some details. Now, IPSEC relies on two main factors when it comes to connectivity, namely your phase one, which I want you to think of as the authentication method. Like, what is the IPSEC tunnel going to be connecting to? How is it going to connect? Like, what type of authentication is it going to use? Is it going to use a password? Is it going to use some type of certificate? How is it actually going to connect to the remote side? And it will also determine the IKE version, or the Internet Key Exchange version. Is it version 1, which is legacy? It's the old stuff. And then version 2, which is a lot newer, where you can define stuff like an ID, and it also just works a bit faster and it has more encryption methods that you can use. And then it's got some base encryption here and stuff like a Diffie-Hellman group. So that is the phase 1, which covers more or less the authentication. And then we get our phase 2 selectors, which I want you to think of the encryption, where you will be defining stuff like which networks you will be allowing to cross this IPSEC tunnel, or which networks you're allowing to communicate with each other. You can leave it as 0000/0000. That just means that anything can traverse the tunnel. It's typically frowned upon to do that for IPSEC configurations because it's a little bit less secure. But if you have a remote site, maybe it's like a dial-up connection, like a dial-up IPSEC connection, and you want to push all of the internet traffic over the tunnel, then it's definitely fine to set it as such. But typically you'd like to just predefine exactly what the source and destination subnets are so that only those are encrypted over the tunnel. And if we go to advanced, it's just more or less some additional features that you can set, like the encryption methods and whatnot again. So let's actually configure our tunnel. Now the first thing that we need to know is we need to know what the remote gateway is. Sorry, I'm going off a tangent here, but I need to explain this with IPSEC as well, because plenty of times when it comes to IPSEC, you are going to be working with somebody else. And I feel like this is where it confuses a lot of people, because you can have everything configured perfectly on your side, but if the remote person mismatches something with their config, then there's a high chance that the tunnel will not establish, and then you're going to have to go into some troubleshooting session. So it's definitely worthwhile to make sure that both administrators of both firewalls come to some form of agreement, like knowing exactly what they're going to be configuring. Are you going to be using Diffie-Hellman? What groups are you using? Are you using dead peer detection? Is NAT traversal needed? Stuff like that. But you'll mainly be just creating some form of a template. And if you are working for an ISP or a company, they most likely already have some type of template like this. So ask them, if you've never done IPSEC before, ask them, can they give you the template so you can just kind of see what it looks like, to understand what type of information they would request from a other administrator, just to ensure that both people are speaking the same language or on the same level, so that there isn't the need to go into some lengthy debugging call. Even though it still happens, you might still go into some debugging sessions sometimes, but I feel that having that type of template just makes it a lot easier to configure the tunnels, because then both ends just know what they need to do. All right, back on point, let's configure this. We are going to say we are using a static IP to connect to. Now I can state what the IP address is of the remote firewall that I'm going to connect to. So this could be your Azure VPN gateway or network gateway, but for me this is just the remote firewall that I've configured, which is 164.0.10. Now the interface is basically going to be stating on which interface the traffic will be sourced as, because you do need to define where the traffic is going to be originating from. So I have two WAN uplinks on this specific firewall, but I know I will be connecting to, or I'll be connecting from this 100.64.255.2 IP. So I'll select WAN 1 as my interface. This is also important because the remote end will need to ensure they connect to this IPv4 or whatever address, or IPv6 address even, as their remote gateway. Now we can set a few additional details. I'll leave everything base set up. I will leave NAT traversal enabled. I'll leave the dead peer detection on. But the main point I want to get here is our authentication. Here we can switch between IK v1 or 2. Again, I strongly recommend using 2 wherever possible. However, some legacy firewalls might have some issues, or even it might be a FortiGate, but it might have a very old version of FortiOS on it, and then it can only support stuff, even though it says v2, it can definitely do v2 most of the times. I find like there's definitely some finicky stuff sometimes. But if you're struggling with v2, just switch to v1, see if you can get the tunnel up that way. But definitely try and always use v2 wherever possible. Now you can select the authentication method. Are you going to use a pre-shared key, or a PSK for short, or a signature? Now signature is more or less just a secure certificate which is verified by both ends, and this will just allow them to automatically use the certificate to authenticate with each other. But we'll just use a pre-shared key. very standard password. And you can use something like a pre-shared key generator to generate a custom password, which is strong. And I definitely recommend making sure your IPSEC passwords are strong. But for our demonstration, I'm going to make it something simple, like 1, 2, 3, 4, 5, 6, 7, 8. Again, I highly recommend not doing that. Use a secure password. Now we get to set our phase 1 proposal. Now this is the encryption on the phase 1 side. Now I typically like to use AES 256, SHA 256, but you can definitely play around with what you feel is more secure. You just need to do some research on what you feel will work best for your organization. We can set our Diffie-Hellman groups, and I typically set this for 5. We can set our key lifetime, and this is important. Even though this seems like such a minimal setting, this definitely needs to match on both ends of the firewalls, and this is just kind of setting how long the key will stay alive. So let's just leave it as that, and we can basically say our phase 1 proposal is done. So let's look at our phase 2 proposal, or our phase 2 selectors. Now here we can determine again what is our local address, and by default your address type is set to subnet. You can click on this and you can change it to something else, and this is quite nice because you could do something like a named address, and then if you have a address or address group, you can reference that in your addresses. But I'm just going to leave that on subnet since we're just doing between 2 basic subnets. Again, that's also why address groups are quite useful, because then you can specify multiple subnets in a single selector instead of having to create multiple different selectors. But let's leave it as subnet, and then I can set my local address, which is 192.168.0.0/24 on this firewall. It's my subnet, my LAN devices. And then my remote address, which is the remote LAN I'd like to access, which is 172.16.0.0/24. Now I can set my phase 2 proposal. Now this is just this encryption. So again, I'm just going to make that AES 256, SHA 256. And I will enable replay detection, and I will also just enable PFS, or perfect forward secrecy, which is just Diffie-Hellman. So I'll put that for 5 again. And I'll leave my key lifetime the default again. I'll click on accept. I'll click on OK. And hey, we've configured a tunnel on one end. Now with FortiGate, even though you configure a tunnel and it's on both ends done, FortiGate is very specific that you also need to ensure that you have matching firewall policies to allow the traffic. And besides the policies, you probably want to add some routing as well, just to make sure that that traffic is being pushed over the IPSEC tunnel. So let's just quickly do that. What I can do is go to my policies and objects, go into my firewall policy, and then I can just create a new policy, and I can say LAN IPSEC access. My incoming interface will be my LAN interface, and my outgoing interface is going to be the IPSEC tunnel, which is currently down. My source I will set as the LAN network, so 192.168.0.0/24, and my destination is going to be 172.16.0.0/24. Now I highly recommend ensuring always that you are as specific on your policies as possible. So let's just call the site BLAN, and then I can just reference that. And we can set our service to whatever protocols we need to allow over this tunnel. But for this demonstration, I'll just set this as all. I am not going to enable NAT because we do not need the traffic to be NATed between these 2 local networks. If there was a requirement, then you would enable NAT for that. I will hit on OK. And we now have a single IPSEC policy to allow traffic from our LAN to the remote side. If I want the remote side to be able to connect, I also need to ensure I have a relevant policy. However, FortiGate does make it easy where you can just right click and you can say clone reverse. And then this will create a policy with your source interface, destination interface, source address, and source or destination addresses just being swapped around. So this we can then say is the IPSEC LAN access. And I could just right click and enable this. So now we have 2 matching policies to allow the incoming traffic and also allow outgoing traffic. Last bit is just adding a static route. I'm going to go into my static routes, add a new route, and then I will say if I want to get to 172.16.00/24, my interface will be the IPSEC tunnel. You'll see the gateway goes away immediately. It just will push the traffic over the IPSEC tunnel. And I can just give it a comment maybe. So I can say this is site B LAN range. Click on OK. And there we go. So the site A FortiGate has been configured. Now we actually need to configure the site B FortiGate. So I'll just navigate onto there. And I'm going to be honest with you guys, it is the same setup, but just in reverse now. So in essence, the only changes should be is that my local and remote subnet should be swapped around. So I'm just going to go into my VPN, go into my IPSEC tunnel, create a new tunnel, set it for custom, call this site A IPSEC or something. Continue. And now I need to configure this with static IP. I'll use the IP address for the site A FortiGate, which is 164.255.2. My interface will be WAN, which is the IP that the site A firewall is connecting to. I will then also just scroll down. I will set this to IPSEC v2. I'll put this for pre-shared key. And then my pre-shared key was 1, 2, 3, 4, 5, 6, 7, 8. We'll set our proposals, which is AES 256, SHA-256. My Diffie-Hellman is 5. And now I'm done with the phase 1. Let's do the phase 2 quickly. I'll set my local address, which is 172.16.00/24. And my remote address is 192.168.00/24. My encryption here is also AES 256, SHA-256, Diffie-Hellman 5. And my key lifetime I'm leaving the same. So I'll just hit on that tick, click on OK. Now we have the tunnel. So again, we will need policies and we will need routing. So let's quickly add the policies. So I'll create a policy here. Let's just say site B LAN, IPSEC access. So here I will define the site B LAN interface. My outgoing interface is going to be the site A IPSEC. My source will be the site B LAN. And my destination will be the site A subnet. So let's just create a new address object for this. Site A LAN. Now my service, I will again just set this for all. I will turn off NAT and I will click on OK. And again, just to quickly create a reverse policy, I'll just right click, clone reverse. And then I can also just give this the name of IPSEC access or IPSEC site B LAN access. Right click and enable the policy. And then let's set our routing quickly. So here I will just say if I want to get to 192.168.00/24, my interface will be the IPSEC interface, but I see the tunnel already established, but that is because we have policies on both ends. And I'll click on OK. And now we actually have a working IPSEC environment. So you know what they say, the proof is in the pudding. So let's actually test this tunnel and see if it's working. So I can just do that by initiating a very basic ping test from one host sitting behind a firewall to something else sitting across the IPSEC tunnel. So I will go into my hypervisor, which is VMware. I'll go to this Windows 10 client, which is a VM sitting behind the site A firewall. And first thing I'd like to see is, can I ping 172.16.0.1, which is the remote end LAN IP. So it's the remote end FortiGate LAN interface IP. So I can ping that. So I'm very happy with that. Can I actually ping 172.16.0.2, which is an Ubuntu VM that sits behind the site B FortiGate? And that I can ping as well. So I'm very happy with this because this means our tunnel is up and running and we are able to push traffic across it. And now I'm just going to show you guys how we can verify some details and troubleshoot some things on the tunnel if we ever need to. So first thing I'd like to do is just navigate back onto my management side. If we ever needed to troubleshoot some type of traffic issue, we can use a flow tool, and this you can do on the GUI or from the command line. But let's do it from the GUI because the GUI is actually super cool since the new version. So what you can do is go onto your network, you can go to diagnostics, you can do a debug flow, and you can just turn on some filters, set it for advanced, and then you can do something like say what your source IP is, so 192.168.0.2, which is my Windows 10 VM, and then I want to see what happens when traffic goes to 172.16.0.2, which is the Ubuntu VM on the remote end. I'll start the debug flow, and let's run a ping again and see what happens. So I'm running the same ping command. Let's go back to our firewall, and there we can see what the flow is looking like, and I love the flows. It actually shows you what the whole thing is doing, like if the traffic's being accepted, if it's being rejected, what's happening. So here we can see the root VDOM received a packet from 0.2 destined to 0.2, well 172.16.0.2 on ICMP, and it will tell you exactly what happened with this traffic. It will tell you which policy accepted the traffic, was it allowed, and here we can see it was entered into the IPSEC interface, so it was basically encrypted, and then it was sent out over the IPSEC tunnel, so we know this is successful. If you want to do this via the command line, because maybe you're using an older version of the FortiOS, like a 6.4 point something, it's as simple as just doing diagnose, debug, flow, filter. First add your filter, so say what your source address is, so in our case it was 192.168.0.2, say what your destination address is, so 172.16.0.2, and then we just need to start the trace. And this is just how long you want this trace to be. So maybe you just want to see the first 9 traces. So I'll set that for 9, and then we can just diagnose, debug, enable. And there we can see I'm still running my ping because it's continuous. And if I just cancel this or type diagnose, debug, disable, you can copy this into a notepad if you'd like, or you can just read this directly and see exactly what has happened. And it's basically the same details. You can see where the traffic came from, where it went to, and the most important bit for us is just to make sure that the traffic was accepted and that it was encrypted and sent over the tunnel. And like that's it. If there was some type of error, you would pick it up on the flow, like if a missing policy was there and the traffic wasn't being allowed. Let's do that quickly. We can emulate it just by going into our policies, and then I can just disable this policy from the LAN to the remote end. Let's just disable that. And I'm going to just run the flow again. I'll just use the network diagnostic tool again for that. So let's do filters. I'm not going to go too deep into it now. I'm just going to say what the source is, because I know the traffic will only be coming from that source. Actually, let's define the destination. Otherwise, I might see internet traffic as well, and we don't want that. So I'll just say 172.16.0.2, start the flow again, and it's busy capturing the packets. And there we can see they are timing out. And we can see, hey, there's definitely something different happening here. So if I stop this flow and we just read through it quickly, we can see it's trying to form that session on that IPSEC tunnel, but nothing else is happening. And this is another place that I actually wanted to show you guys, is if you need to also just troubleshoot some very basic stuff with your IPSEC tunnels, you can come into the system events and then VPN events, and it will show you exactly what's happening with all of the VPN events. So all of the tunnels, if you configure multiple tunnels, you can see what the tunnel is, and it will basically just tell you if the tunnel has been successful. You want to see that it does install this IPSEC SA, which is just Security Association, and then that should mean that the tunnel is up and running. Let's just quickly make sure that our tunnel is still up. It is up, but as you know, our stuff is failing because of the policy, so let me just re-enable that. Now, here's one big thing that I want to actually just show you guys, and this is more or less relating to if you really want to deep dive your troubleshooting with the IPSEC to see why things aren't working, then just let's break this tunnel quickly just by changing the PSK. So I will just go to my VPN IPSEC tunnels and I will change my PSK to something else. So it's wrong. So maybe I'll make it 87654321. Save that, okay it. And now in theory, my tunnel should go down. There we can see the tunnel has dropped. So if we want to diagnose our tunnels to see what's happening, I highly encourage this from the command line. So let's head into the console, but really guys, you need to think of the console as your friend. It's there to help you. I can promise you, this is going to be where you're going to find the most information if you're ever running into some issues, because let's just open this up and we're going to be debugging the application now, or the IKE application. So we'll do a diagnose debug application, IKE. I'll just type -1, but that'll just basically be telling us for how long it's going to be debugging the stuff. And then if I do a diagnose debug enable, we're going to start getting a ton of different log messages or debug messages of what's happening with this tunnel or all of our tunnels. If we had multiple tunnels, it might get a bit messy. So in that case, you could filter the traffic based off of a very specific tunnel name, just so you only see things related to that specific tunnel. So here we can see already there's a bunch of logs. And I'm just going to try and reinitiate the tunnel by going into the dashboard. I'll go into my IPSEC monitor and I'll just right click here to try and bring up the tunnel. And this is also something you can do if you ever see your tunnels just down and you want to try and force the tunnel up. You can right click in your IPSEC monitor on the tunnel that's down and just try and bring it up this way. But this is just in essence forcing traffic now over the tunnel. So if I go back to my command line, we should see there's a bunch of different things here. And I can already see the error message why it's not working. But let's just copy this to the clipboard. And I'll just do a diagnose debug disabled so we stop getting spammed by the messages. And then I recommend just pasting this into a notepad, because now you can properly go through all of the logs or the debug messages to see what has happened. So if we scroll down, we can see how far the firewall gets to actually trying to connect. But if we look at these log messages specifically, we can see that it's received an auth message, it's got the identifier, it's trying to authenticate, and here we know is our issue. It sees that the authentication failed, and it's telling us PSK auth failed, probable pre-shared key mismatch. So now we can tell the guy on the remote end, hey, I'm seeing this in my log messages. It's telling me that we might have the incorrect keys. Can you just confirm that you're using the correct key? And then you just send them the key again. And then most likely they're going to type in the new key and the tunnel will come up afterwards. But what's nice is this is not just for determining if somebody's typing in the key incorrectly. You'll see many different details on here. Like here you can see the phase 2 details that we're trying to use to negotiate. It will even pick up what the remote end is sending you, and then based off of that you can then see, hey, they might have the wrong Diffie-Hellman group, or they might have the wrong encryption method, and then you can just update your method silently so that they don't even know that you fixed it that way. But it's always best to use whatever agreed method you guys have stated. So then reach out to the person, tell them, hey, I can see that you're not sending me the correct authentication method. Update it to this, please. Once they make that update, I can assure you your tunnel will come up. And I want you to understand it's so fun to troubleshoot these issues, because it allows you to see what's happening with the packets, and then you can determine exactly what the problem is and, you know, find that fault, finally fix it, and it just feels so good. All right, I actually think this is where I'm going to end off this lesson, because this should just be an introduction to getting an IPSEC tunnel up and running. But also I want to show you how to troubleshoot some basic give you some basic troubleshooting skills when it comes to IPSEC tunnels, especially the diagnose debug application for the IKE. It will give you so much information to work with. Anyways guys, this is where I'll end off the video. I hope you had fun. I hope you learned something new. And again, I'd like to thank my Patreon and YouTube members for helping support the channel, and I'll catch you guys in the next video. See ya.